What if the Milky Way you think you know, the soft white river in the summer sky, the pretty spiral on posters, looks completely different from almost every perspective that actually exists in the universe? What if our galaxy is only our in the sense that we live inside it, while the cosmos itself doesn't give it a front, a back, or a favorite angle? Tonight, we're going to ask a strange question, not how you see the Milky Way, but how the universe sees it. Welcome back, traveler. Tonight we drift through science. You're lying there in a dim room, maybe with headphones on, the glow of your screen soft against the walls. Outside, your part of the Milky Way is just a quiet neighborhood of stars circling a center you'll never visit. Before we wander too far, if this kind of calm cosmic storytelling helps your brain slow down, you can gently like the video, subscribe for more nights like this, and, when you're awake enough, tell me in the comments where on this galaxy you're listening from, and what time your little corner of starlight is living right now. Maybe you didn't come here because of galaxies at all. Maybe you're here because your mind wouldn't power down with the rest of the day. Thoughts looping about money, about messages, about people you care about, or things you wish you'd done differently. It's okay. You don't have to force yourself to focus, and you definitely don't have to track every detail we touch. If your thoughts drift away, if you forget the numbers, if you fall asleep halfway through, you're not failing anything. You're doing exactly what this was meant to help you do. Tonight we'll move through different layers of perspective. We'll start with the view from your own patch of Earth, where the Milky Way is a streak above your ceiling. Then slip into imaginary views from nearby stars, from our satellite galaxies, from the local group, and from the cosmic web itself. We'll visit the human side too. Observatories perched on mountains, satellites in silent orbits, surveys and simulations where people try to reconstruct how our galaxy must look from the outside, even though we're trapped on the inside. It's the universe's portrait of us, drawn from the clues we've managed to collect. Think of this as a very slow pan outward and inward at the same time. Outward into larger and larger frames where the Milky Way is just one more swirl of light. Inward into the feeling of being a small, sleepy observer inside that swirl. There's no exam at the end. You don't need to memorize distances or remember which cluster is which. You can simply let the images roll past like scenery through a train window. If you like, you can dim your screen. Feel your body settle a little deeper into whatever you're lying on. Close your eyes if that's comfortable, and let's take the first gentle step into a night where the galaxy is not something you're looking at, but something you're inside, while the universe, in its quiet way, looks back. On some nights, if you could switch off every street lamp and billboard, the sky wouldn't be black at all. A soft milky arch would rise above you, not a clean line, but a hazy river, bright in some patches, scratched by dark lanes in others. That river is not above your life so much as wrapped around it. When you look at that band, you're not seeing an object far away. You're looking sideways through the body of the galaxy you live inside. Viewed from the ground, the Milky Way feels like a ceiling painting. It stretches from horizon to horizon, a streak that seems glued to some dome. But the shape you're actually seeing is depth, not decoration. The glow comes from countless distant stars, whose light overlaps until your eyes can't pick them apart. Dust clouds drifting between you and those stars carve out dark gaps, like smoke lying in front of city lights on a foggy night. Astronomers learn to interpret that glow as structure. Put simply, the Milky Way is a flattened, rotating system, a disk of stars and gas with a central bulge, extending roughly 100,000 light-years across. Your sun sits about halfway out from the center, embedded in one of the spiral arms. To the universe, that whole disk is one coherent mass distribution. To you, it's a strip of brightness your eyes can only ever cut through from the inside. Long before anyone knew the word galaxy, people noticed the band and told stories about it. In different cultures, it was a spilled drink of the gods, a celestial river, a path of birds, the backbone of the night. Those myths weren't wrong so much as sideways. They captured the feeling of a continuous thing that outlived generations. The universe didn't change as the stories did. It simply kept the stars where they were, letting meanings shift beneath them. The first serious attempt to turn that feeling into a map came from simple counting. In the 18th century, William and Caroline Herschel swept the sky with telescopes, dividing it into small fields and tallying stars in each one. Where the Milky Way band crossed, the counts soared. Away from it, they thinned. From these patterns, the Herschels drew a sketch of a flattened grindstone of stars, with the sun seemingly near the center, a bold guess based on the view from one seat inside the disk. Picture that work for a moment: a cold observatory, the faint smell of metal and wax, Caroline calling out numbers, William recording them by candlelight. Above the roof, that same hazy river drapes across the darkness. Inside, each glittering point is becoming a mark on a page, and those marks turn into a crude cross-section of the structure you're now imagining. The universe doesn't care about the sketch. It already knows the true shape in the language of gravity. As techniques improved, the sketch was revised. Jacobus Kapteyn, in the early 20th century, used larger catalogues of stars to build another model, again finding a lens-shaped system with the sun suspiciously central. What he didn't yet account for was dust, interstellar clouds, dim, distant stars, making the outskirts of the disk look artificially empty. The Milky Way, as the universe experiences it, was always much larger. Our early maps were like floor plans drawn from a single dusty room. The real expansion of scale came with new kinds of distance markers. Henrietta Leavitt's work on Cepheid variable stars provided a way to gauge how far certain stars truly are by how they pulse. Using such standard candles, astronomers realized that some clusters and gas clouds were far farther than assumed. The disk had to stretch. The sun slid off center on paper. The Milky Way that had once seemed like a modest island began to look more like a continental shelf of stars. Back in your own body, none of that math is visible. What you feel are simpler things: the weight of blankets on your legs, the faint glow of a screen, maybe the hum of a distant appliance. You might live under skies where the Milky Way never appears, drowned in artificial light. Even so, you carry an inner picture of it, probably a polished spiral seen from above, a logo more than a landscape. It's a useful symbol, but not the way the galaxy actually meets you. Inside the universe's awareness, there is no preferred viewing angle. The Milky Way doesn't switch to a face-on pose when someone wants to understand it. It simply exists in 3 dimensions, every star and gas cloud moving along its path. Our diagrams, top-down spirals, side-on cuts, are compromises, projections that squeeze a complex body onto a flat page. They tell part of the truth and hide the rest, the way a shadow hints at a shape without revealing its depth. Modern missions try to rebuild that depth from the inside. Gaia, for example, measures positions and subtle motions for over 1 billion stars, turning parallax and proper motion into a partial 3D map. In that map, the Milky Way stops being a painted smear and becomes a swarm, stars streaming around the center, bending where unseen mass tugs, forming ripples and warps. It's closer to how the universe experiences our galaxy, as a pattern of orbits, not an icon. Inside the data rooms where that map is made, the work is surprisingly quiet. Screens full of plots, code scrolling, coffee cups abandoned beside keyboards. Outside those buildings, the actual galaxy arches overhead, its starlight crossing the void as it always has. Inside, rows of numbers settle into shapes, A warped disk here, a central bar there. For the universe, this is just bookkeeping catching up to reality. For us, it's our internal Milky Way gradually coming into alignment with the one that actually exists. All of this happens far from the concerns that brought you to this moment. Whatever kept you awake, money, messages, health, something you said or didn't say, has nothing to do with the tilt of the disk or the length of the bar. Yet the same laws that keep stars in their orbits are keeping you pressed against the bed, held gently to the surface of your planet. The galaxy's presence in the universe and your presence in this room are parts of one continuous physical story. You might think of the Milky Way as a forest, dense trunks fading into mist. From where you stand, you see only the avenues between nearby trees. From above, the forest has a clear outline, a pattern of clearings and thickets. The universe sees the forest as the total arrangement of roots, trunks and leaves all at once. You see one path. Neither view is wrong. They just answer different questions about the same quiet collection of matter. As the breaths you take grow gradually slower, you can let this first layer settle. You live inside a band of light that is not really a band at all, but your cross-section through a galactic disk. The universe doesn't elevate that disk above others. It simply lets it be one more arrangement of mass and motion. In the next stretch of the journey, that disk will start to rotate and shift in your mind as we imagine how the Milky Way appears from other stars and other angles, while your body stays exactly where it is, under its own small patch of that river of stars. Think for a moment about how different your own city looks from one neighborhood to another. A skyline that dominates one horizon disappears behind low buildings in another. The Milky Way is like a city of stars, and the view from your address is just one of many. Move the sun inward toward the galactic center, or outward toward the edge, and the sky above an inhabited world would change, even though the galaxy as a whole stays the same in the universe's ledger. Nearer the center, the luminous band would thicken and brighten. The glow of densely packed stars would crowd the sky, and dark dust lanes might cut more dramatically across it. Far out in the disk, that same band would look thinner, more fragile, as if it could be brushed away. Each location sees its own version of the Milky Way's ceiling. From the universe's perspective, these are just different lines of sight through one object. To the beings who might live there, each sky would feel uniquely theirs. To understand this, astronomers build models and ask a simple question. If I place an observer here, what would they see? They populate a simulated disk with stars and gas, then compute the brightness in different directions as if a tiny eye were embedded in that model at the sun's position or somewhere else. When those synthetic skies resemble what we actually observe, it's a sign the underlying model is closer to the galaxy the universe has been hosting all along. Imagine staring at a monitor where the Milky Way's disk is rendered in cross-section. A dot marks you are here. A slider moves the dot inward or outward, and the simulated sky on the side of the screen reshapes itself, band thickening, star clouds shifting, the central bulge rising higher. Outside the lab, the real galaxy doesn't morph in response to the mouse. It simply spins. Inside, our mental picture is learning to detach from the accident of our specific seat inside the disk. Of course, no one has flown far enough above the Milky Way to snap a photograph of it from outside. We infer its face-on shape by analogy and by data. When we observe nearby spirals like Andromeda or Triangulum, we're looking at cousins from the outside. Their arms, bulges, and dust lanes offer clues about what our own galaxy must look like from some imaginary vantage point above its plane. The universe already sees us that way, in a sense. Gravity doesn't care which side is up. Radio astronomy provides another angle. Neutral hydrogen gas in the disk emits at a characteristic radio wavelength. By mapping this emission and measuring how it shifts due to motion, astronomers reconstruct the spiral pattern of gas even where dust hides stars. On those maps, the Milky Way appears as a set of winding arms, not as the smooth band you see with your eyes. The universe accounts for both, the stars and the gas, as parts of one mass distribution. Our senses need instruments to keep up. Picture one of those radio dishes, enormous and still in a quiet valley. By day, it's just metal against sky. By night, it listens. Signals arrive as tiny fluctuations in voltage, too faint to mean anything until computers stack and clean and map them. Eventually, on a screen, arcs and clumps appear that trace spiral arms. No one watching those images form has to remember that, to the universe, these arms are not drawn in ink. They are flows of matter, guided by gravity alone. Infrared observations add another layer. Dust that looks like darkness in visible light glows softly at longer wavelengths, revealing structures hidden from ordinary sight. In these images, the central bulge of the Milky Way swells, its true size and shape more evident. The galaxy starts to look less like a flat smear and more like a thick, textured object with a bar of stars through its core. Again, the universe has always known this bar as a region of enhanced mass. Our pictures are simply catching up. From where you're resting, this constant redrawing of the Milky Way might feel distant, but it has a subtle effect on how you imagine your place. The more angles we reconstruct, edge on, face on, gas only, dust only, the more your inner picture shifts from a single, fixed postcard to something more holographic. The galaxy stops being a flat logo and becomes a volume you're immersed in. A structure whose appearance depends entirely on where you're sitting and what you're capable of sensing. A metaphor can help here too. Think of being in a dense fog with scattered lanterns. From your position, the pattern of light suggests certain paths and shapes. From a drone hovering above, the distribution looks different. Clusters and corridors you couldn't see from the ground. The fog itself, in this metaphor, is the Milky Way. The universe experiences every lantern and curve of mist at once. You only ever see the slice that passes through your eyes from your spot on the floor. It's easy, lying in bed, to feel that your view is the default one, and that all maps and diagrams are somehow subordinate to what you can see if you step outside at night. In reality, the raw night sky is one highly filtered cross-section of the galaxy. Your atmosphere, your latitude, your light pollution, even the sensitivity of your retinas, all are masks between you and what's actually there. Instruments and models aren't less real. They're our way of approaching how the universe sees the same object. At the same time, there's something precious about that limited, ground-level view. No simulation can reproduce the feeling in your body when you tilt your head back and let your neck relax, the air cool on your face, the faint sense of depth as stars seem to hang at different distances. That feeling doesn't appear on any map. The universe doesn't track it. It lives only in nervous systems like yours, on planets like this, tucked into corners of disks like the Milky Ways. So there are two Milky Ways coexisting in your mind now. One is the band you might or might not have seen with your own eyes, the streak that once guided travelers and inspired stories. The other is the imagined whole, a spiral warped and barred, full of gas and dark matter, glimpsed through others like it and reconstructed by instruments. Neither cancels the other. Together, they bring you a little closer to the galaxy as the universe includes it in its fabric. As your breathing grows a fraction deeper, you can let these different perspectives line up for a moment. The ceiling band, the edge-on disc, the face-on spiral, the radio arms, the infrared bulge. All of them are attempts, from one tiny corner, to approximate how a much larger, indifferent cosmos already treats the Milky Way as a single, ongoing arrangement of matter and motion, no more and no less. In the next quiet turn, that arrangement will be placed among its neighbors, and your home galaxy will begin to shrink into one ordinary member of a small crowd, even as it remains, for you, the only galaxy you'll ever truly live inside, far above your imagined position in the galactic disk. Other islands of light begin to come into view. The Milky Way no longer fills the frame, it shares the stage. One glowing oval hangs just over there. That's Andromeda. A smaller, loosely wound spiral lurks nearby, the Triangulum Galaxy. Around all three, like bits of glowing debris in a shallow tide pool, scatter dozens of tiny dwarfs. Your home has neighbors, and the universe files all of them together as a single gravitational family. Astronomers call this little community the local group. It stretches across roughly 10 million light-years, with the Milky Way and Andromeda as its heavyweights, and a crowd of smaller galaxies tagging along. To the universe, this is a modest clump, one stitch in the wider cosmic fabric. On the scale of all that exists, it's almost provincial. But compared to the scale of a single human life, this neighborhood is already so vast that your familiar galaxy now looks like just one more swirl. You might imagine labeling each galaxy with a simple card: mass, size, type. The Milky Way's card would mention a barred spiral about 100,000 light-years across, with 1 trillion solar masses of matter when you include the dark halo. Andromeda's card would list slightly higher numbers. Smaller dwarfs would have more humble stats. In a cosmology database, all of these entries line up in neat rows. The universe reads them only as contributions to the overall pattern of mass and light. Our knowledge of the local group didn't come from any single photograph. It grew from measurements of distance and motion. Redshifts and blueshifts tell us whether a galaxy is moving away or toward us. Standard candles reveal how far their light has traveled. Andromeda's spectrum, for example, is shifted slightly toward blue, signaling that it's headed in our direction. Combined with its distance of about 2.5 million light-years, that motion writes a slow script. The two giant spirals will eventually merge. Picture a spectrograph at work. Light from Andromeda enters the instrument and spreads into a rainbow, sliced by thin, dark lines where atoms have absorbed specific colors. Those lines appear nudged from where they'd be in a lab on Earth. On a screen, that nudge becomes a tiny horizontal shift, a few pixels at most. To the scientist, it means approach. To gravity, it means inevitability, a long, graceful fall that will play out over billions of years, reshaping the local group. Step back again in your mind, and the details of any one galaxy begin to blur. The local group collapses visually into a single luminous knot when placed next to richer gatherings like the Virgo cluster, which hosts thousands of galaxies. Surveys chart the positions of these knots across the sky. On those maps, the Milky Way's home cluster is just another dot among many, no more or less ornate than countless others. The universe accounts for it without special emphasis. Huge projects like the Sloan Digital Sky Survey translate this cosmic census into pictures we can grasp. Each galaxy becomes a point of color on a 3D plot. Rotate that plot, and vast strands of structure emerge. Filaments, walls, and chains. Somewhere on one of those strands lies the local group. No highlight box pops up automatically around it. Only when a human hand moves the cursor, their does here become significant. In the physics alone, it's just another node. Meanwhile, space telescopes like Hubble have stared at seemingly blank patches of sky until they filled with thousands of faint galaxies. The famous deep fields show spirals, ellipticals, and irregular smudges layered at different distances and times. The Milky Way itself isn't visible in those images. It's the vantage point, not the subject. In that sense, the universe sees our galaxy as one of the lights contributing to someone else's deep field, a background object in another corner of the sky. From your bed, this demotion from the galaxy to one of many might sting at first. A place that once felt like the central hub of everything is now just a typical entry in a catalogue. But there's another way to frame it. If the Milky Way were wildly exotic, governed by different rules than other systems, physics would be patchy and parochial. The fact that our home fits comfortably in the general pattern means the laws you learn here apply almost everywhere. Think of living in a small town that turns out to be built with the same bricks and street layout principles used around the world. At first, it might make your town feel less unique. Then, slowly, it might make the world feel more reachable, more coherent. In the same way, learning that the Milky Way is an ordinary barred spiral can make the universe feel less like a collection of separate miracles and more like one continuous, intelligible fabric you happen to inhabit. On the level of lived experience, though, you never feel this ordinariness. You don't wake up thinking, I reside in a statistically typical galaxy group. You feel your mattress, the air in your room, the obligations waiting on the other side of sleep. The local group doesn't announce itself when you brush your teeth. The universe's view and your view overlap only in thin slivers, a night sky, a diagram you remember, a passing moment of awe. Emotionally, being one galaxy among many can trigger two opposing reactions. One is a sense of insignificance. If our entire home system barely stands out, what could your individual life possibly mean? The other is a surprising sense of belonging. You're not an exception in a hostile void. You're a small part of a pattern that repeats. Galaxies gather in groups. Groups nest in filaments. Within at least one of those galaxies, matter has learned to wonder. You ride that chain all the way down. The universe itself doesn't register your reaction either way. Gravity doesn't fluctuate when someone feels tiny, and dark energy doesn't pause for reassurance. But your nervous system does respond. Studies of awe suggest that contemplating these huge scales can shrink your sense of self-importance just enough to loosen the grip of everyday anxieties. Your worries don't vanish. They simply stop being the only things on the stage. The local group and beyond move in behind them like a silent backdrop. If you let that backdrop come into focus for a moment, you might notice a strange kind of intimacy hidden inside all this distance. Every galaxy in those surveys, every dot on those maps, is made from the same fundamental ingredients, playing by the same rules, embedded in the same expanding space. The Milky Way is not singled out, but neither is it excluded. It belongs. And because you belong to it, you're indirectly threaded into that larger belonging too. As your breathing smooths out, you can imagine the local group as a handful of lanterns drifting together in a vast dark hall. The universe registers their glow and their mutual pull, nothing more. Inside one of those lanterns, in a room on a small world, a single person is lying down listening, trying to make sense of where they are. In the next turn of our journey, we'll shift attention from this neighborhood view toward the subtler ways the Milky Way leaves its fingerprints on its surroundings, streams, halos, and gentle imprints, and how those, too, fold into the universe's quiet accounting. Gravity is the first way the universe notices the Milky Way. You feel only a tiny slice of it as the weight of your body pressing into whatever you're lying on, the gentle insistence that keeps you from floating away. Scale that up unimaginably, and the galaxy becomes a curved depression in space-time, a trough carved by stars, gas, and dark matter. From that perspective, the Milky Way isn't an image at all. It's a shape in the invisible fabric everything else moves through. Deep inside that curvature, stars orbit the center in vast loops. Near the core, they race. Farther out, they move at stubbornly high speeds that refuse to drop the way simple models would predict. When astronomers plot those speeds against distance, the curve stays flat where it ought to sink. To the universe, that flatness is just how mass is distributed here. To us, it's a sign of something we can't see dominating the galaxy's gravitational story. The name we give that unseen component is dark matter. It doesn't glow or absorb light. It apparently passes through ordinary matter almost without noticing, interacting mainly through gravity. Yet it outweighs all the shining stars combined. Wrapped around the bright disk in a vast diffuse halo, it defines how fast things orbit, how tightly satellites are bound, how the Milky Way sits in the surrounding cosmic web. In the universe's accounting, this invisible halo is as real as any star. Understanding that halo comes from watching motions, astronomers measure the speeds of stars in the outer disk, track the orbits of globular clusters, and map the paths of faint stellar streams looping around the galaxy. When those paths curve in ways visible, matter alone can't explain. Extra mass must be there. In quiet offices, people nudge parameters in models, run simulations again, and check whether the synthetic orbits now match the observed ones. Each improvement is a small step toward the universe's effortless picture. Light is another way the Milky Way announces itself. Not just the narrow band your eyes are tuned to, but the full spectrum: radio, infrared, visible, ultraviolet, X-rays, gamma rays. In radio waves, cold hydrogen gas outlines spiral arms. In infrared, dust that seems black in optical images glows like embers. In high-energy bands, hot gas and violent events punctuate the halo and core. Taken together, these wavelengths form a kind of multicolored whisper the galaxy sends out in all directions. To catch that whisper, telescopes specialize like sensors. One instrument listens in radio, another in infrared, another in X-rays. Each sits on a mountain or orbits above the atmosphere, patiently collecting photons that left different parts of the Milky Way long ago. On their own, the images can look abstract. False colors, strange textures, layered together. They reveal something closer to how the universe experiences the galaxy, not as a smooth milky band, but as a restless, structured, many-temperature cloud of matter and light. You can imagine one of those observatories high in a dry desert. During the day, its dome is just another pale shell against blue sky. At night, the slit opens, the mirror turns, and the building becomes an eye. Inside, detectors are chilled, so their own warmth doesn't drown out the signals. Outside the Milky Way arches silently overhead. A few hours later, that arch has turned into rows of numbers on a screen. Brightnesses, wavelengths, positions, ready to be rearranged into maps. Beyond gravity and light lies time. The universe doesn't freeze the Milky Way in any one pose. It has watched this galaxy assemble itself from smaller fragments, draw in gas along filaments, flare with bursts of star formation, and settle into quieter phases. That whole history is encoded in the motions of stars, the ages of clusters, the chemical fingerprints in stellar atmospheres. From the cosmos's point of view, your galaxy is a long-running process, not a snapshot. To replay that process, scientists run simulations on supercomputers. They start with conditions that mimic the early universe: tiny fluctuations in density, dark matter particles, gas clouds, and let gravity, hydrodynamics, and cooling laws evolve them forward. In their virtual cosmos, Halos form and merge, disks spin up, bars appear, satellite galaxies fall in and are shredded. When one simulated system ends up with mass, rotation and structure resembling the Milky Way today, it offers a plausible version of the movie the universe has already screened. In those simulation labs, the light is often the glow of monitors alone. Blocks of code scroll past, progress bars inch along, 3D visualizations of galaxies bloom and collide. Outside, the real Milky Way is invisible behind the roof, still turning, indifferent to the digital copies. Inside, people compare synthetic rotation curves to observed ones, count virtual satellite galaxies, tweak feedback recipes. It's a quiet, persistent attempt to align our invented stories with the galaxy's actual trajectory. From where you are, the timescales involved are almost impossible to feel. A single orbit of the Sun around the Milky Way's center takes about 220 million years. In that span, continents drift, species rise and vanish, mountains erode. Your entire lifetime barely moves the galaxy a fraction of a degree along its path. The universe sees the full arc. You experience only a sliver thinner than a pencil line on a long spiral. There's something unexpectedly gentle in that mismatch. The Milky Way doesn't hurry because you are stressed. It doesn't slow when you are tired. Its rotation, its star formation, its slow exchanges with neighboring galaxies go on at their own pace, free from human urgency. Remembering that can loosen the sense that everything important has to be resolved tonight. The galaxy you inhabit is in no rush. You are allowed to step out of the race for a few hours too. Think of the Milky Way as a great slow wheel turning in the dark. Gravity shapes its rim, light traces the spokes, time keeps it moving. The universe registers only that it turns, that its mass curves space, that its radiation contributes to the background glow. Inside, on one tiny point along that rim, a person lies awake, feeling both the weight of personal worries and the faint tug of curiosity about that enormous, indifferent wheel. Both are real, just painted on different scales. If you let your attention soften, you can hold a very simple image. A luminous disk with an unseen halo, wrapped in its own gravity, radiating across the spectrum, evolving so slowly that to you it might as well be still. That's the Milky Way as the universe includes it in its story. You as out tonight are the part of that system that has become aware enough to wonder how it looks from the outside. The laws didn't change when that awareness appeared. They just started being watched from within. In the next quiet stretch of this journey, we'll let the focus drift from the galaxy's raw structure to the quieter, more personal fact that, in at least one small nook of this spinning system, matter has arranged itself into minds that can feel, remember, and rest. For now, you can stay exactly where you are, letting gravity hold you, light dim around you, and time stretch gently forward while the Milky Way continues its unhurried turn in the dark. Far from being a perfectly clean disk, the Milky Way carries a faint cloud of companions and scars around it. If you could dim the galaxy's main light and boost only the outskirts, an intricate halo would appear. Tiny galaxies orbiting like sparks, star clusters arcing along long paths, thin streams of stars tracing graceful loops. To the universe, these details are just test particles in a gravitational field. To us, they're clues, handwriting in the margin around our home. Two of those companions are bright enough to catch the naked eye from southern skies, the large and small Magellanic Clouds. From the ground, they look like detached smudges, as if someone brushed a thumb across the stars. In reality, they're dwarf galaxies in motion, tugged and stretched by the Milky Way's gravity. Gas strips away from them, forming a long, faint ribbon called the Magellanic Stream. curling behind like a wake in deep, dark water. Star streams crisscross the halo as well. Long ago, small galaxies wandered too close and were slowly pulled apart, their stars smeared along their orbits. Today, those stars still travel together, forming slender rivers that wrap around the Milky Way. In simple simulations, these show up as tidy arcs. In real data, positions, velocities, they emerge only after careful filtering, like hidden trails revealed by adjusting contrast on a photograph. Each one is a memory the galaxy carries in its outermost light. Gaia and other surveys have turned those memories into recognizable paths. When scientists plot stars in unusual coordinate systems aligned with potential orbits, structures that once looked like random scatter suddenly cohere into lines and clumps. A background of points becomes a delicate lacework of streams. The universe has let these structures exist for billions of years without commentary. Only now are we learning to see them as sentences in a longer story about how the Milky Way has grown. Imagine, for a moment, looking at the galaxy not in visible light, but through the soft glow of ancient stars in globular clusters sprinkled around it. Each cluster is a dense, spherical hive of old suns, arcing high above and below the disk. Their orbits and ages help outline the shape and age of the halo itself. To gravity, they're just compact knots of mass. To observers, they're like beacons hanging in the invisible outskirts, marking where the galaxy's influence still holds. Beyond these discrete companions, the Milky Way contributes to a faint background glow that fills intergalactic space. Every star that has ever shone here adds a little to the diffuse extragalactic background light, starlight scattered and redshifted over vast distances. It's not something you could ever see with your eyes. It's more like a low, omnipresent hum only the most sensitive instruments can detect. In that hum, our galaxy's voice is just one thread woven among billions of others. High-energy particles and elusive neutrinos also drift outward from our spiral. Supernova explosions accelerate cosmic rays that leak into surrounding space. Nuclear reactions inside stars produce ghost-like particles that fly right through planets and people. Most of them never interact with anything. To the universe, they are bookkeeping. Conserved energies moving along straight paths unless deflected. On Earth, buried detectors built in ice or deep rock wait for the rare case where one leaves a faint telltale mark. Gravitationally, the Milky Way participates in an even subtler effect. It slightly bends light from more distant objects passing near its mass. This weak lensing, as it's called, is usually overshadowed by larger structures like clusters and filaments. But in principle, our galaxy's halo contributes a small ripple to the lensing field. The universe doesn't label that ripple. It's simply part of how mass is arranged. Only when we measure distortions in background galaxies do we begin to suspect our own halo's ghostly outline. If you zoom in emotionally instead of physically, all of this feels very far from your day. Streams, halos, subtle lensing, particle backgrounds. They're hard to connect to the softness of your pillow or the ache in your shoulders. And yet, quietly, these are the ways the Milky Way is not isolated. It trades stars with smaller companions, shares radiation with the surrounding darkness, leaves fingerprints in fields of particles and light. Your galaxy is not a sealed snow globe. It's porous, in conversation with its environment. One image that might help is to think of the Milky Way as a ship moving through a nearly invisible ocean. Smaller boats sail alongside, some breaking and leaving debris in the wake. Waves radiate outward from engines and collisions. The water itself bears the traces of the ship, long after it has passed, ripples that soften and spread. No single ripple stands out from far away, but taken together, they describe where the ship has been and how it moved. Your own life has its equivalents. You leave trails in other people's memories, in the small changes your presence makes to their days. Most of those traces are soft and quickly blurred by time. They don't show up on any grand ledger. In that sense, you and the Milky Way share a kind of anonymity, real effects, faint and distributed, folded into a much larger background where no one is keeping dramatic score. Existence itself is the only requirement. The universe, as far as we can tell, doesn't prefer clean edges. Halos fade gradually, streams break into clumps. Background light has no sharp boundary. Everything blends into something else at the margins. There's a kind of kindness in that. It means there is space for half-finished stories, for influences that were small, for connections that never resolved neatly. The Milky Way's outskirts are full of remnants and overlaps, and yet the galaxy still holds together as a whole. If you let that idea seep inward, it becomes easier to accept the blurred zones in your own life, relationships that didn't end cleanly, projects that never quite reached the version you imagined, feelings that are not simply good or bad. The universe doesn't insist that every structure be tidy. It allows ragged edges and still counts the galaxy as complete. You can allow yourself that same tolerance, at least for the span of one quiet night. Somewhere out in those outskirts, a star might be drifting along a stream, its motion still shaped by an encounter that ended billions of years ago. No one is there to watch it. No mind records its path. Yet the star keeps circling, obedient to a gravitational story written long before Earth existed. The universe tracks that story only as an arrangement of mass. You, on the other hand, can choose to find something strangely beautiful in the fact that such unwitnessed patterns persist. When you exhale and feel your body sink a little deeper, all of these distant structures continue unchanged. Streams keep looping, dwarfs keep orbiting, faint glows keep spreading. Nothing in the halo knows whether you've decided to rest or to worry. And still somehow, knowing that the galaxy's outer fingerprints are so delicate and long-lived can make your own immediate concerns feel lighter, as if they, too, might be just one small trace in a much larger, softer field. It raises a quiet question that doesn't need an answer right now. If the Milky Way can carry so many subtle marks of past encounters in its invisible outskirts, how many traces might your own life be carrying, barely noticed, but still shaping the path you're on, long after the moments that created them have faded from memory? For most of human history, the Milky Way was defined by what could be seen, that hazy arch, scattered stars, occasional nebulae. Only recently did it become clear that the universe treats the visible part almost like an afterthought. Most of the galaxy's mass is not in the stars you'd sketch or the gas clouds you'd paint. It's in something you can't see or touch, something that doesn't flicker or glow, yet silently dominates the way everything moves. The first hints came from the way stars orbit in the outer disk. If only the luminous matter mattered, their speed should drop with distance, the way planets slow as they get farther from the sun. Instead, those velocities level off and stay high. Plotted on a graph, the curve looks stubbornly flat, refusing to sink. That flatness is the galaxy telling you, in the language of motion, that most of its weight is in an invisible halo wrapped around the shining disk. The name dark matter is really more of a label for our ignorance than a description. Whatever it is seems to ignore light almost completely, interacting mainly through gravity. It passes through stars and planets and your own body like a ghost, leaving no direct sensation behind. Yet its collective pull shapes the Milky Way's rotation, anchors its satellite galaxies, and ties our home into the larger cosmic web. The universe, of course, never had to name it. It simply includes that mass in the way space-time curves. To probe this hidden component, Detectors are buried under mountains, sunk into mines, frozen into Antarctic ice. They wait for an incredibly rare event, a dark matter particle bumping into an atomic nucleus, just enough to produce a tiny flash or a faint electrical signal. Most of the time, nothing happens. Years can pass with only background noise. Still, people keep watching, because even one clear collision would turn that vague label into something more concrete, anchoring our picture of what the galaxy is really made of. Wrapped around that mystery is another, larger one, the way space itself behaves on vast scales. Observations of distant supernovae and the cosmic microwave background suggest the expansion of the universe is speeding up, as if some pervasive energy is stretching space-time. We call this dark energy, another placeholder for something not yet understood. The Milky Way, along with every other galaxy not tightly bound to its neighbor, drifts within this accelerated expansion like a leaf on a slowly widening river. From where you lie, acceleration of the universe doesn't show up as anything you can feel. Your room doesn't stretch. Distances between furniture stay the same. Gravity inside the local group overwhelms whatever dark energy is doing out there. And yet, on scales far beyond your personal horizon, that gentle push determines the long-term fate of groups, clusters, and filaments, including the patch that hosts your galaxy. The universe sees all of this simply as the current solution to its equations. There's something almost comical in how lopsided the bookkeeping is. By mass energy content, normal matter, the stuff that makes stars, planets, skin, blankets, phones, accounts for only a small fraction of the total. The rest sits in categories we label dark, not because they're spooky, but because we don't really know what they are. Still, for you, the small visible slice is everything. The taste of water, the warmth of a bed, the light of your screen, the memories that rise when you close your eyes. Even within that visible slice, your vantage point is limited. Thick bands of dust in the galactic plane block large regions of the sky and optical light. Certain directions will always be murky if you rely only on your eyes. Astronomers switch to radio and infrared, thread together partial views, and correct for biases. They publish maps annotated with contours, color scales, error bars, visual reminders that any human picture of the Milky Way is stitched from incomplete glimpses, unlike the universe's seamless, uninterpreted account. In observatories and data centers, you'll find people leaning over plots that are never quite as clean as they'd like, points scattered around best-fit lines, noisy backgrounds, ambiguities. They argue gently about systematics, calibrations, alternative models. Behind every neat infographic of the galaxy lies that messy underlayer of almosts and maybes. The cosmos doesn't fret about those details. Its behavior is what it is, regardless of how closely our graphs hug the data. The anxiety and the curiosity are entirely ours. If you let that realization sink in, it can soften the pressure you put on yourself to understand everything about your own life. The Milky Way is composed mostly of unknowns and partly of things we see only from awkward angles, and yet it exists fully, without apology. You, too, are made of parts you can name and parts you can't quite articulate, motives and memories you only half grasp. Imperfect comprehension doesn't stop either of you from being real. There is also a quiet kindness in how indifferent the galaxy is to our confusion. Dark matter doesn't become easier to detect because we're frustrated. Dark energy doesn't slow its work because we're nervous about the future. The Milky Way's halo, disk, and bar continue to do what they've done for billions of years. Inside one tiny corner of that system, a single person lies awake, wrestling with uncertainties on a much smaller scale. The mismatch in concern can be oddly liberating. Imagine the universe as a stage where most of the set is painted in colors we can't see yet. Under ordinary lighting, you notice only a few props. Under ultraviolet or infrared, more shapes appear. Dark matter and dark energy are like portions of the scenery that only reveal themselves under conditions we're still learning how to create. For now, we move through the play knowing the backdrop is richer than what we can perceive, and that not seeing it clearly doesn't stop the story from unfolding. All this invisible structure can make you feel lost, but it can also act as an invitation to loosen your grip on certainty. The galaxy you inhabit is not fully mapped and may never be. The universe's view is complete in a way yours can't be, and that's okay. You don't need a finished diagram of the Milky Way to rest tonight, just as you don't need a finished diagram of your own future to take the next breath. As your body grows heavier against the mattress or sofa, nothing about dark matter or dark energy changes. The unknown components of the cosmos continue to shape the large-scale fate of everything, while the known components carry the textures of your immediate world. You don't have to resolve that contrast. It can simply sit beside you, like another quiet presence in the room, a reminder that being surrounded by mystery is not a failure, but the normal condition of existing in a universe like this. And somewhere in that thought, a strange possibility opens up. If most of what makes the Milky Way what it is will always lie beyond direct sight, what does that suggest about how much of your own story might be unfolding in ways you can't yet perceive? Subtle shifts, slow arcs, future convergences, already written into the fabric, even while, tonight, all you can really feel is the rise and fall of your breath in the dark. Wherever you look in the wider universe, the Milky Way appears as a system of mass and light, moving under gravity's rules. But inside one thin band of its disk, something quietly different has happened. Matter there has learned to feel. At a purely physical level, a neuron firing is just chemistry and voltage, no more magical than a star fusing hydrogen. Yet the experience attached to it, hurt, relief, or boredom, is something the equations don't register, even while they fully govern the process. From a distance, life on Earth barely registers against the galaxy's glow. The Milky Way would shine almost the same if your planet were sterile rock. Star counts, rotation curves, halo mass, all those cosmic statistics would hardly notice whether oceans teem with organisms or remain empty. In the universe's bookkeeping, Earth is a small temperate world around a midlife star in a quiet arm. The secret that it hosts forests, cities, late-night thoughts never appears in any line item. And yet, the conditions that allow those thoughts are deeply tied to the galaxy's history. Before your star existed, earlier generations of stars in the Milky Way fused hydrogen and helium into heavier elements, then exploded, seeding the surrounding gas with carbon, oxygen, iron, and more. New clouds formed from that enriched material. Your sun and planets condensed from such a cloud about 4.6 billion years ago. To the universe, that is ordinary chemical evolution. To you, it is the ancestry of every atom in your body. Astronomers track this enrichment with a simple measure: metallicity, the abundance of elements heavier than helium in stars. Younger suns near you tend to be richer in metals than older ones. Stars in the inner galaxy often carry even more. When plotted across the disk, these abundances form gradients that tell a story of recycling and mixing. Embedded in those graphs is the quiet fact that complex chemistry, necessary for oceans and proteins and brains, depends on billions of years of previous stellar generations. It helps to imagine the Milky Way as an enormous kitchen that started with only 2 ingredients. Early stars were simple ovens, baking heavier elements inside themselves, then scattering them when they died. Over time, the pantry filled: carbon for organic molecules, silicon for rocks, phosphorus for DNA, iron for cores and hemoglobin. From far away, this is just nucleosynthesis and feedback. Up close, it's why you can drink water, build houses, or feel a heart quicken at a remembered voice. Not every corner of the kitchen is equally inviting. Close to the galactic center, intense radiation, frequent supernovae, and complex gravitational tides may make it harder for long-lived, stable environments to persist. Far out in the disk, there may simply be less material to build rocky planets. Your solar system orbits in a relatively quiet, metal-rich suburb, not too crowded, not too empty. No glowing sign hangs over this zone, but its conditions quietly raise the odds that worlds like yours can exist. Researchers sometimes call this fuzzy band a galactic habitable zone, though it's more a useful idea than a sharp border. Surveys of exoplanets show that rocky worlds can form around many types of stars, yet their actual climates and histories depend on countless variables. The universe doesn't draw a ring around your orbit and mark it as special. It simply lets stars and planets form wherever physics allows, and on a few of those planets, chemistry crosses an invisible threshold into biology. Zoom in further, and the galactic background recedes. On the scale of a planet, what matters are oceans, atmospheres, plate tectonics, magnetic fields. The Milky Way sets broad constraints: what stars are possible, what elements are available, but it doesn't choreograph tides or rainfall. Still, those local details are the way you encounter the galaxy. The air in your lungs, the water in your cells, the calcium in your bones all carry a memory of having once been dispersed as gas high above the disk. Astrobiologists try to connect these scales. They study microbes clinging to boiling vents and frozen deserts, test how life tolerates radiation and vacuum, and model climates on distant worlds. Their work hints that once conditions are right, living systems might appear in many different niches, adapting to extremes that would seem lethal from a human perspective. But the actual frequency of such sparks across the Milky Way remains a blank in our tables. The universe already has a definite answer. We are still guessing. That uncertainty drops you into an odd dual possibility. If life is common, your awareness tonight is one of countless flickers scattered through the spiral arms, most too far apart to ever share a word. If life is rare, you might be part of a tiny minority of matter that has ever wondered anything at all in this galaxy. Either outcome changes nothing about the way stars orbit the center, yet both can make your skin prickle in the dark for very different reasons. It may help to notice that, on the scale of your feelings, the statistics don't matter as much as they seem to. Whether there are a trillion other minds or only a handful, your experience of being awake in this room is still singular and immediate. The Milky Way could be teeming or mostly quiet. The fact remains that, here and now, one patch of stardust has formed a nervous system that can worry about work, remember a childhood afternoon, or be lulled by thinking about galaxies. In a sense, awareness is the Milky Way folding back on itself locally. Most of the galaxy's mass just follows the rules, blindly tracing orbits, fusing elements, radiating energy. A very small fraction has become capable of modeling the whole, imagining what the disk looks like from outside, drawing maps, naming structures, feeling humbled or comforted by the view. The universe doesn't treat that as a new category of matter. But for the part that feels, and the shift is enormous. None of this changes what the galaxy is to the wider cosmos, a curved distribution of mass and light, moving through expanding space. The rotation curve doesn't kink because someone has a realization. The halo doesn't thin when a person lets go of an old regret. And yet, inside one tiny region of that mass, stories are being told about what the Milky Way means. and those stories shape how a few brief lifetimes are lived. In that narrow sense, the galaxy acquires a kind of internal echo. Thinking along these lines can tilt in two directions. One tilt leads toward a heavy feeling. If the universe doesn't recognize or remember any of this, do your efforts matter at all? The other leads toward a softer conclusion. Matter in this galaxy took billions of years to arrange itself into someone who can feel warmth, dread, affection, curiosity, someone who can lie awake and let their thoughts roam from their own worries to the far edge of the spiral. Maybe that's enough. Somewhere above you, beyond roof and atmosphere, the Milky Way is exactly what the universe has always seen. A luminous, rotating structure wrapped in an invisible halo. Nowhere on that structure is there a mark indicating that tonight, on a small planet partway out on one arm, a mind is turning these ideas over, letting them slowly loosen the day's tight knots. And yet that unmarked place is where the difference between mere matter and felt existence quietly plays out. For as long as your eyes remain open, time behaves strangely when you hold it up against the Milky Way. On the scale of the galaxy, everything about your life is a brief shimmer. Stars take tens of millions to billions of years to burn through their fuel. Spiral arms rearrange themselves over hundreds of millions. Halos grow as small galaxies fall in across eons. Against that backdrop, a single human lifetime is thinner than the line of a pencil drawn across the rim of a huge circle. If you imagine the sun tracing its orbit around the galactic center, your entire personal history occupies barely a fraction of a degree of that path. In the time between your birth and your last breath, the solar system moves only a tiny step along its 220 million-year loop. The universe reads the whole orbit in one continuous equation. You experience only a few pages near the end of one small chapter, with no way to flip ahead. Astronomers tease out the galaxy's long story by looking at stars of different ages. Massive, blue stars live fast and die young, marking regions of recent star formation. Smaller, red stars can burn quietly for tens of billions of years, outliving even the current age of the universe. Ancient clusters in the halo hold stars almost as old as the cosmos itself. Their light reaches us as a kind of fossil record, telling of epochs that ended long before Earth's crust cooled. From your vantage, time is measured in humbler units: work weeks, rent cycles, birthdays, unread messages. A bad hour can feel heavier than an entire quiet month. A single conversation can bend your sense of before and after more sharply than any galactic merger. Neuroscientists would say your internal clock is hitched not to absolute seconds, but to emotion, novelty, attention. The universe keeps a steady beat. Your mind speeds and slows the music without asking permission. The mismatch between these layers of time doesn't mean one is wrong. It just means they're answering different questions. Galactic timescales tell you how disks settle, how halos build, how long stars like the sun will shine. Human timescales tell you whether you can rest tonight, whether tomorrow's tasks feel possible, whether memories from years ago still tug at you as if they were happening in the next room. Both clocks tick inside the same physics. Memory is your brain's way of stitching your tiny segment of galactic history into something coherent. But memory is not a perfect recording. Each time you revisit an event, you rewrite it a little, emphasizing some details, erasing others. Two people can share an experience and carry away different versions, both deeply real to them. The Milky Way doesn't store these narratives. It keeps only the physical traces, a few altered synapses, the faint metabolic cost of recalling a scene while you lie awake. Psychologists sometimes describe autobiographical memory as a story you tell yourself about yourself. That story has chapters, themes, recurring characters. It has shadows where you avoid looking, and bright spots you return to for comfort. None of that appears in any catalogue of the galaxy. The Milky Way doesn't know which days you count as turning points. It doesn't even know what a day is. It knows only that your planet rotates and that its axis is tilted. If you place your life story next to the galaxies, something interesting happens. The big arc, formation, growth, slow transformation is written mostly in unfeeling matter, following simple laws. Your arc is written in feeling matter, using the same laws but with an extra layer, significance. A star exhausts its fuel and collapses. A person leaves a job or a relationship or a city and feels the ground shift beneath them. To the universe, these are just different energy distributions. To you, they are completely different kinds of events. Melancholy often creeps in when you sense the gap between how deeply things matter to you and how lightly the universe carries them. A regret that has replayed in your mind for years leaves no mark on the galactic halo. A fear about the future does not ripple the spiral arms. That can feel cruel at first, as if the cosmos is indifferent to what hurts you. In a way, it is. But that indifference also means nothing out there demands that you keep suffering. You can think of the Milky Way as a very old tree in whose branches you've built a fragile nest. The tree doesn't record which days were windy for you, which mornings felt impossible, which nights brought a quiet peace. It just stands, rooted in the laws that hold it up. Your memories are the soft lining of that nest, twigs, bits of string, shed feathers woven together. They don't need to endure for billions of years to have mattered while you were tucked inside. There's a temptation to believe that for something to be meaningful, it must somehow be permanent, or at least cosmically acknowledged. But most of what the galaxy does is temporary on some scale. Spiral arms are patterns, not objects. Star-forming regions ignite and fade. Streams disperse. Even the disk will change shape over time. The universe doesn't pause to certify any of these phases as significant. They simply happen, and then something else does. Your phases are allowed to behave the same way. Seen from that angle, the brevity of your life stops being an insult and starts being a kind of mercy. You are not required to carry your past forever with the same weight. There is no cosmic rule insisting that tonight must feel like last year, or that old choices must keep defining you. The galaxy you inhabit has reinvented itself countless times in silence. Inside one small mind, reinvention can be slower and messier, but it is just as permissible. The Milky Way's long memory is physical, not emotional. It remembers mergers in the orbits of stars, not in stories. You remember in stories first and only faintly in physiology. Both kinds of memory can be softened. Gravity will eventually smear out even the sharpest stellar stream. Your brain, given enough time and kindness, can dull the edges of sharp images that once felt unbearable. Neither process is fast, but both tend to move in the direction of smoothing. If you let that idea drift through you, your own timeline might feel a little less rigid. The big dates on your mental calendar are still there, but they sit inside a context where everything changes, even if it does so slowly. You're not stuck in a frozen frame. You're part of an unfolding process, just as the galaxy is. The difference is that you get to feel your way through it, moment by moment, instead of watching from outside. Somewhere far above and beyond your ceiling, ancient clusters continue their long orbits. Newly formed stars brighten in distant arms, and the central bar turns almost imperceptibly. None of those processes knows how old you are, what you regret, or what you hope for. Yet you, from this tiny patch of space-time, can hold both your own short story and the galaxy's long one in your mind at once. What does it do to the weight of your worries when you realize that both of those stories share the same quiet, unhurried background of time? From where you lie, the Milky Way still feels enormous. Let the mental camera keep drifting backward anyway. The disk that once filled your whole sky now shrinks to a bright almond. Farther out, it becomes only one bead on a faint string of other galaxies. Those strings intersect and loop, leaving wide, almost empty regions between them. This is the scale where the universe stops looking like a collection of separate pictures and starts to resemble texture, a web of light threaded through darkness. Surveys like the Sloan Digital Sky Survey turn this texture into something you can see. Each galaxy, including your own, becomes a dot on a three-dimensional map. Its position and redshift turned into coordinates. When millions of dots are plotted together, patterns emerge without anyone asking them to. Sheets, clusters, filaments. Somewhere in that lattice sits the local group, with the Milky Way tucked quietly inside. Unless you label it, your home is just one point among all the others. In a dim control room, you can imagine a researcher rotating such a map on a screen. The web swings, filaments slide past, voids open and close like black lungs. Click, and the view zooms into a small knot. Click again, and the knot resolves into individual galaxies, each with its own disk or bulge or irregular smear. The Milky Way is one of them, unremarkable in its stats. To the universe, this lack of special treatment is just honesty. The cosmic microwave background adds another layer to this view. That faint afterglow from the early universe carries tiny temperature variations, ripples only a few parts in 100,000. Those ripples mark where matter was slightly denser or thinner just after the Big Bang. Over billions of years, the denser spots grew into the filaments and clusters we see now. The location of your galaxy traces back to one of those gentle bumps. The universe remembers it purely as a statistical fluctuation. Inside your skull, the story sounds different. You carry a specific childhood, a handful of people who changed you, fears that wake you up, hopes that keep you moving. None of those show up in any map of large-scale structure. The cosmic web doesn't know which node contains a person grieving or laughing or listening to science to fall asleep. It only knows that somewhere along one filament, a galaxy of a certain mass and type is quietly rotating. That disconnect can feel brutal at first. If the universe doesn't register you, is your life just an accident folded into a bigger accident? Yet look again at how much had to line up for this accident to occur. Early universe ripples, dark matter halos, galactic mergers, generations of stars, stable orbits, liquid water, chemistry spiraling into biology. None of it was aimed at you, but all of it is present in you. You are, in a literal sense, a very small, very local way the web is expressing itself. Cosmologists talk about cosmic variance. On these larger scales, we only have one universe to observe, one realization of the underlying statistics. There is no second cosmos to compare with. In that framework, the Milky Way is not just one galaxy among an infinite sample, it's one particular outcome in a single, finite experiment. Your life, in turn, is one particular outcome inside that outcome. The odds of this exact configuration are unimaginably low, and yet plainly, here you are. Consider how your mind reacts when you stand under a clear night sky, far from city lights. A sense of smallness often arrives first, but if you stay with it, another feeling can surface, a thin, surprising thread of connection. The atoms in your skin come from stars that once shone in some other arrangement of the Milky Way. The neurons that fire when you feel awe are following rules shaped by that same cosmic history. You are not looking at the universe from outside. You are the universe, noticing itself from one angle. Laboratories and telescopes make that noticing more precise, but not more real. A supercomputer simulating the growth of cosmic structure, a radio array mapping neutral hydrogen, a satellite measuring microwaves, all of them are extensions of the same basic phenomenon. Matter in this galaxy has organized into forms that ask questions about the whole. The universe doesn't elevate these questions above any other configuration of particles. The meaning we feel in asking them is ours, not etched into space-time. Once you see it that way, the hierarchy of importance flips. On the scale of the cosmic web, the details of your day truly are negligible. On the scale of your inner life, they are everything. Both statements can be true at once without contradiction. The Milky Way can be both a forgettable dot in a survey and the cradle of every thought you will ever have. The universe doesn't resolve this tension for you. It simply allows both perspectives to exist. There's a kind of gentle relief in letting go of the demand that your story be cosmically validated. The filaments won't rearrange themselves when you finally feel okay. The voids won't contract if you make a mistake. But nothing out there insists that you be more than what you are either. You're not a failed galaxy. You're a person on one world inside one spiral with a limited radius of care. Within that radius, your choices and kindnesses are not small at all. Imagine, briefly, that you could float far enough away to see the entire cosmic web at once. Every galaxy would be reduced to a point of light. The Milky Way would be indistinguishable from its neighbors. Somewhere inside that one point, a tiny creature would be lying down, listening, trying to reconcile the distance between their worries and this enormous, quiet network. From that hypothetical vantage, would their efforts look absurd or strangely beautiful? You don't have to answer. The question itself does something subtle. It tilts your perspective without erasing anything. Your bills, your relationships, your unfinished tasks still matter. They just sit now against a backdrop where galaxies themselves are background noise. The Milky Way's place in the universe is both trivial and unavoidable. Yours is too. Maybe the real puzzle is not whether that makes you important or unimportant, but what it makes possible for how lightly you're allowed to hold your own story. If you strip away names and stories, the Milky Way is simple, a distribution of mass and energy, evolving under a small set of rules. Gravity curves space. Matter follows those curves. Radiation leaks into the dark. On that level, there is no home, no edge, no inside or outside. There is only configuration. Yet from your position in a quiet room on a small world, it doesn't feel that way at all. It feels like you live somewhere, and that somewhere matters. Part of that feeling comes from boundaries much smaller than a galaxy. The walls of your room, the edges of your street, the language you think in, the people whose faces you can recall. These are the contours that define here for you. The Milky Way sits far outside that immediate frame, and yet it shapes everything inside it. The strength of gravity at Earth's surface, the spectrum of light from the sun, the chemistry available for bodies and brains. There's a sense in which you are citizen of the galaxy, whether you like it or not. Your atoms were assembled here under its particular mix of element abundances and star formation history. Your planet's orbit is part of its disk dynamics. Your nights, when you can see the sky, are painted by its stars. The universe doesn't issue passports, but if it did, yours would list this barred spiral as your place of origin, your only place of residence so far. That citizenship isn't earned by achievement. You didn't have to understand stellar evolution to be allowed to exist. You arrived already entitled to a portion of starlight, a share of oxygen, a patch of surface to walk on. The Milky Way did the heavy lifting long before you appeared, building elements, assembling disks, calming down enough for stable orbits. By the time your part of the story began, the stage was prepared without ever having been designed for you specifically. From the universe's side, all of this is just neutral process. The fluctuation becomes a halo. A halo acquires gas. Gas forms stars. Stars seed heavy elements. Planets condense. Nowhere along that chain does a bell ring to announce conscious life incoming. Yet, at some point, in at least one corner of this galaxy, patterns of matter began to model their surroundings. Remember, anticipate, and suffer. The rules didn't change. Only the flavor of what it feels like to follow them did. Sometimes that awareness makes everything feel heavier. Knowing the scale of the Milky Way and beyond can amplify your sense of smallness, as if your life were a brief glitch occurring in the margins of a giant calculation. But there's another way to lean on the same facts. If you are small, then so are many of the things that trouble you. They fill your field of view, but they are not actually large on the scale that built you. Think of an ant walking along the trunk of an old tree. A knot in the bark might feel like a mountain range, a drop of sap like an ocean. The tree itself just stands, unaware of these dramas. The Milky Way is something like that tree, and you are the ant, except that, unlike the ant, you can also imagine the whole trunk, the forest, the sky. You can let your sense of terrain expand, even while your actual steps stay small. When your thoughts spiral around a problem, the mental camera zooms in. The issue swells until it fills every direction you look. No room left for stars, for galaxies, for webs of structure. Remembering where you are in the cosmos doesn't make the problem vanish, but it widens the frame. The worry shrinks back to its real size, significant close-up, negligible from far away. Both views are legitimate. Being able to toggle between them is a quiet kind of skill. The galaxy's indifference can be harsh if you treat it as a verdict on your worth. It becomes softer if you treat it instead as permission. Nothing about the Milky Way insists that you be successful by any particular definition. The stars do not require you to be constantly productive. The halo does not grow thinner when you rest. In a universe where most things simply follow their paths, you're allowed to let go now and then of the demand to be exceptional. Belonging, on this scale, is not about being noticed. The Milky Way will never recognize your name or remember your decisions. Belonging is more basic. Your existence is compatible with the fabric you're in. Your body is stable in this gravity. Your chemistry fits with these elements. Your mind can operate within these temperatures and pressures. You don't need cosmic applause. You only need to not be rejected by the rules, and you aren't. You're already here. If you picture the galaxy as a vast, dimly lit hall, most of it lies in silence. Stars burn like candles scattered across the floor. In one corner, a tiny lamp flickers more erratically. That's consciousness rising and falling, bright when awake, dim when asleep. The hall doesn't tilt toward that lamp. It doesn't rearrange itself. But while the lamp is on, it illuminates a small circle. And within that circle, meanings appear. You live entirely inside that circle, never seeing the hall directly. Knowing that the hall is vast and quiet doesn't force you to discard the meanings in your circle. It simply anchors them. Your cares do not expand to fill the universe. They occupy a valid local patch. Others elsewhere will have their own circles of light, with their own constellations of concern. The Milky Way contains all of these without comment. Its role is not to approve or disapprove, but to be stable enough that such circles can exist for a while. There is a gentle paradox hidden in all this. The more clearly you see how little the galaxy depends on you, the more free you are to live a life that feels honest on your scale. If the Milky Way will spin whether or not you send that message, change that habit, forgive that person, you're liberated from cosmic stakes. What remains are human stakes, people you affect, including yourself, in a tiny radius. Within that radius, your choices matter intensely. As your awareness drifts at the edge of sleep, the Milky Way is being seen by the universe only in the most minimal way, as mass motion, radiation, no commentary, no story, no verdict. Yet inside one of its arms, on one rotating stone, a mind is holding two truths at once: that it is almost nothing on the largest scales, and that it is, at the same time, the entire world from its own point of view. What might loosen in you if both of those truths are allowed to be quietly, peacefully true at once? You've walked in your mind, from a hazy band above the roof of your life to a spiral of stars, to a small group of galaxies, to threads of light woven across the universe, and then all the way back to the quiet place where you're lying now. Along the way, the Milky Way has changed shape: ceiling painting, disk, halo, dot, texture. For the universe, it was always just one continuous arrangement of mass and motion. For you, it became a way to think about where you belong. We traced how your galaxy looks from different seats inside it, how its arms and bar and halo reveal themselves through carefully collected photons and motions. We watched it gain neighbors in the local group, then lose its uniqueness in vast maps of structure. We let it wear invisible components, dark matter, dark energy, that never touch your skin directly and yet quietly decide how it rotates, how it sits in the web, how its story unfolds on scales you'll never feel. We also kept coming back to smaller things: the temperature of your room, the weight of your body on whatever is holding you up, the way your worries cluster much closer than any group of galaxies. Against the galaxy's timeline, your life is almost impossibly brief. Against your own inner timeline, certain afternoons or conversations can feel infinite. None of that tension shows up in a rotation curve. It lives entirely inside nervous systems like yours, nested in one arm of a barred spiral. Some of what we explored lives firmly in the realm of data and models, surveys, simulations, spectra, elemental abundances. Some of it lived in metaphor, the galaxy as a forest, a ship, a hall, a tree. All of it circled around one simple idea: the way the universe sees the Milky Way, as mass, light, curvature, is very different from the way you experience it, as backdrop, story, comfort, question. Neither way is wrong. They just answer different kinds of why. Along the way, the galaxy's indifference turned out not to be a verdict on your worth, but a kind of spaciousness. The Milky Way doesn't demand that you be impressive. It doesn't watch your successes or your mistakes. It simply provides gravity, elements, stability, light. Within that neutral framework, existence itself becomes the only prerequisite. You don't need to justify your presence to the spiral. You arrived already woven from its matter, already allowed to take up a small circle of space and time. We looked at how much had to align for this to happen at all. Early universe ripples, halos forming, gas cooling, stars living and dying, elements stacking up, planets condensing, chemistry tipping over into biology, biology into minds. None of that was aimed at producing you, yet all of it is now present in you. In that sense, when you lie here thinking about the Milky Way, the galaxy isn't just something far away. It's folded into your blood, your bones, your breath, participating from the inside. If you've drifted in and out while listening, if some of the science blurred at the edges, that's perfectly fine. The galaxy doesn't require you to remember its statistics. The point was never to pass an exam. It was to give your thoughts a wider field to wander through, so that your own day might feel a little less cramped. even if all that remains in the morning is a soft impression of rivers of stars and long, patient time. That's enough. Thank you for lending your attention, even if only its last sleepy fraction, to this journey through your home galaxy. Out of all the ways you could have spent this slice of your life, you chose to share it with a story about where you are in the universe. That trust is not something the Milky Way can appreciate, but it's something I can acknowledge from here. If you fell asleep before hearing this, that's not a failure. It's the script doing exactly what it was meant to. If by any chance you're still awake at this point, it would be strangely beautiful to hear from which corner of this galaxy you're listening, and what time of night it is where you are. Scattered across one spiral, there are people lying under different pieces of the same disk at different hours, sharing variations of the same curiosity. If you want more nights like this, slow, calm, wandering through science, you know you can tap the usual buttons so this little corner of the Milky Way finds you again. Sooner or later, the screen will dim, the room will reclaim its darkness, and your thoughts will finally loosen their grip on the day. Outside, the Milky Way will continue its unhurried turn. Streams will keep looping. Distant clusters will keep their long orbits. Inside, muscles will slacken, breathing will settle, and awareness will narrow down to something simpler than galaxies. For a while, you won't be a mind thinking about a spiral at all. You'll just be a body resting quietly within it. And when sleep finally takes you, nothing in the universe will fanfare the moment. No star will flare, no halo will shift. Yet in that small pause, something gentle happens. The part of the galaxy that has been straining all day to solve problems and hold itself together is allowed to dissolve into the same unself-conscious existence as the stars. Matter stops asking what it means and simply is countless. Warm under a blanket on a world circling a star, halfway out in a barred spiral, the universe registers only as a curve in its endless, quiet fabric.